So in today's video, we are going to learn about depth first search algorithm. Depth first search algorithm is a traversing algorithm used in tree and graph-like data structures. It acts like a stack, means whatever data which is stored in DFS, it is stored in stack. Elements are added into the stack one at a time. One by one elements are added in this and searching is from left to right. So how DFS will work? Searching is from left to right, means left to right searching occur, and then it travel depth wise. Depth wise it travels and backtracking is implemented in DFS. Backtracking we will see in our program, then you will easily understand what is it. So first of all, it moves like this. So A is first visit its neighboring nodes like B, then it visit B's neighboring node D. But after D, it will not have another neighboring nodes, so it will goes towards E. Then it will go back and move to C, and afterwards F and G. So this BFS travels like this way. First of all, it will see node, its node A, then it will check that A has two nodes like B and C. So it will go first of all left side, it will visit left side node B. Then it will check B has its child nodes or not. If B has child node, then it will goes towards D. Then D will not have any child node, so it will goes towards E because B's second child node is A. Then this process is implemented in right side also. So this is the basic DFS concept which we learn in this diagram. So after that we will see how this code. So in this code, we define that our graph looks like this. Like we define a variable graph, in that we give this A has B and C as its child node, as we can see here that A has B and C as its child nodes. Then B has D and E. So B has D and E. Then we write C has F and G. So this is done here. So after that D will not have any child node E, F, G. So we define it as empty because it will not have another child nodes. So this is graph that we give in our program. Then what is this? Visited is equal to set. So this variable is used to store whatever elements our graph, whatever elements in our graph they are visited. So visiting nodes are stored here. So it will know that this node is already visited. Okay. So this is only for storing our nodes. So this function we define here like DFS. In this we give three parameters like visited, graph and node. What is this? So it is visited. In visited, whatever nodes which are travels, so that nodes are stored here. In graph details are present, and in this node variable currently which node is present, that is stored here. So after that we will give one condition like if node not in visited. So it will check that whatever node we define here like node A, so node A is not in visited, it will check that node A is in that visited list or not. If it is not in that visited list, it will print that node, and then visited dot add node means in this visited it will add that A node, and afterwards it will check that A will have its neighboring nodes like A will have its child node or not. So in this line for neighbor in graph node, in this node variable which value is stored? A. So currently A value is stored, so it will check that graph means node A will have its neighboring node. Then if it have its neighboring node, then it will recursively call this function like visited graph, and then A will have its neighbor like B. So B value is there and it will recursively call this function, and this is the basic code that will run when we execute. So here we pass, because for node we have to pass some value. So here we define node A. So this is the simplest algorithm or program we can say. So whenever we run this, so we will get this output. How this occur? Like A, B, D, E, C, F, G. So you can see here A, B, D, E, C, F, G. So this output we want here, and it will display it.